Hi everyone, welcome to Skilled Inspirational Academy. This is a free CCNA Day 5 class. Here are the list of topics we are going to discuss today. So let me start with IP addressing first because that's been for a long. So I'll start up with IP addressing. Then we will look at what is TCP IP, what's the difference between TCP IP, and what's the key difference between OSI and TCP IP model. Then followed by a recap about the stacking. Let's get started. Yeah, I'll open my whiteboard. I think this picture would be very helpful for you being a beginners. It's very helpful to visualize what is the IP schema we should use and what is the difference between private address and public address, all that. So all the enterprise organization, your broadband, maybe your broadband network for your phones, everybody, we would have seen this IP, right? This is more familiar. So most of us, we use the IP address, the same range, 10 network, right? But have you ever imagined that how everybody is using the same IP address, but the request is going out to Google, Yahoo, whatever, in the internet, you're trying to reach any destination or maybe any application. Say, for example, here, google.com, but how the request is coming back to the same user. Because if the request is coming with the same range, IP range, there will be definitely some sort of confusion, right? So we'll discuss about all that. So primarily, I have to give you an understanding about what is IP address. How do we actually say it is an IP address? There is an identity for everything in the network, right? So how we are differentiated with the names, in the same way the host in the internet, right? They are distinguished with the IP address. That's how you can distinguish, right? How do you say it's a source and destination? That's purely based on, the host and destination is based on your IP address. If I say this is a source, I should definitely have an IP address as a source. Then network terminology. So if it is a destination, definitely it should be a valid IP address. So we might have seen this for ages because we are using this in our day-to-day life. We have your mobile phones, everything. You happen to see this, but why this has a specific structure? The IP address, at the moment when you see, you can find this as an IP address. You can distinguish this with a normal number, decimal number. That's because of this dots, right? Always the IP address, it will be represented with dots, something like 10.0.0.1, 20.0.0.2. So it is basically divided with dots, and every dot inside, that's called 8-bit address. Okay, can you see that? So totally 8 bits inside one segment. So that is called, it's 4832, sorry, 4 into 8 equal to 32-bit addressing. They call it as IP addressing as a 32-bit addressing. Why? In every octet, they say octet is 8, right? In every octet, you have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This makes my first octet, followed by the second octet, 6, 7, 8, followed by the third octet, 1, 2, 3, 4, 5, 6, 7, 8. Then the last octet, fourth octet, 3, 6, 7, 8. So totally, if you count this, you'll get 32 bits. Why this representation? That is important. Why we need this representation? Because this IP ranges is everything from the ground. It's been developed from the same logics. But the key thing here to consider is we got three ranges. That's class A, class B, and class C. This is common. This has been used everywhere. Class A, class B, and class C. And the range, it starts from 10.0.0.0 and it ends with 10.255.255.255. And I'll tell you how we get these values. And always remember one thing, the IP address that always start, maybe it should be the range of 1 to 255. It will not exceed anything, something. Do you ever seen an IP address like 256? No, that will not happen, because the range of the IP address is from 1 to 255. Anywhere, if you see, this is between 1 to 255, between the range 1 to 255. This is range between 1 to 255, right? This is 192, but not 256 or 257. That's not out of range. That's always between 1 to 255. That is a primary thing and the primary understanding about the IP range. You should know this. And followed by that, let's see what is class A, class B, class C. For now, class D and class C, I'll explain tomorrow. But for now, to give a basic understanding, you'll just go with this, because this is used for multicast and this is reserved address. And we'll definitely discuss about that. But I don't want to confuse you much, because this is a first subnetting class. So it's mostly this is more into a mathematical calculation. I don't want to confuse everyone. So that's the reason I'm giving you, simple representation as possible. So let's take this. This is called as a class A. The range is 10 network. This is most widely used. And class B, yeah, and the range is 172.16.0.0. It's never going to change. And it ends with 172.31.255.255. And the class C, 192.168.0.0. I think in the broadband modem, I believe we should get this IP address. If I check the IP address of my PC, it would be in the same range. Let me check. And I have accessed the switch here. I'll take one more command prompt. Okay. So if I give IP config, so what is my, here I'm trying to find my wireless adapter. You see this is my wireless adapter. By looking at this, I can say this is class C. Why? Because this is a basic representation given here. It's class C address starts with, class C address starts with this range 192.168.0.0. And I can see the same range here, 192.168.137. So by looking at this values, I can find out this is class A, class B, or class C. It's a very important question in CCNA. You would definitely see this. What is class A, what is class B and class C, by just looking at the range. And this is the public IP address range. Okay, this cannot be used for domestic purpose. I mean, you cannot use this in a private range. Have you ever seen somebody, they got an IP address with 128.0.0.1, the broadband connection? I don't think so. It is purely used for public access. This is, unique address that's given for every organization, I would say. You can use one common public IP address that cannot be used for private addressing, because the IP address is very limited, right? We got millions of users out there. If they start giving it, then definitely they will run out of the IP address. So public IP address never used. And this is private address range. And you might have a question, then how come this private address range is serving millions of people out there? We have a different concept called natting. Through natting, all the address, whatever you see here, that's not the actual address that's routed on the internet. That will be changed. That will be changed from private to public IP. It will go as a one public IP out. And we have a separate topic that's called NAT. We will discuss more about NATing in the upcoming classes. But for your understanding, just look at what is IP addressing, what is the different category of IP addressing. That we got three different classes. One is class A, class B, and class C. And by looking at the ranges, you can distinguish class A, class B, and class C. And here, every time when we give an IP parameters, we give three details, right? Let me open a different whiteboard. I think the image will be deleted here. Whenever you assign an IP address, you will do three parameters, right? One is, the first thing you will give your IP address. Example 192.168.0.1. And I said this 192 range is class C. I have assigned this IP address, right? Your host address. And then followed by subnet mask. Example. And then gateway. Maybe a gateway example in the same range. The gateway should always be in the same range, right? So how this physically looks like? I got a gateway, something like a router with a gateway. Here I have configured the gateway. And this is my PC. And this is my IP address. So both should be in the same range. That's a basic criteria. But how we are calculating the subnet mask? I'll tell you, this is very basic. There are different ways of doing subnetting. People, they do subnetting different way. I'll show you the easiest way, which I follow all the time to do subnetting. So let me take this example. Okay, so class A, I'll go back to the chart. That would be helpful for you to follow me. Okay, let me take this picture. Let me zoom in a little bit. Okay, so what is the default CADR value? See here, this is called CADR value, the lost value. This 24 is CADR. This is classless inter-domain routing. CADR stands for classless inter-domain routing. What do you mean by that? So if you actually see this 10 network, I'll go back again to empty whiteboard. Let's take this example. Okay, so 10,000, because I said in every octet we got 8 bits, so it forms 32-bit addressing, right? I'll tell you how we can convert this from decimal to binary. If you would have seen this, I'll do it this way. See, the maximum value is 255, right? In every bit 255 is the maximum. I'll tell you how I derived this value. So how do I get this value? See, if you can split like this, 255. If I divide it by 2, 212, 224, 2714, right? Remainder 1. So it gives me a value of 128. So I am basically, I am segmenting this 255 into multiple parts. I am making this one value, this decimal value, I'm converting this back to binary, right? I'm actually segmenting the data. It's not segmenting the data, sorry, segmenting the number 255 into 8 parts. So again, I'm dividing by 2, 2612, remainder 2361. So it gives me a value of 64. Same way, 236, 224, sorry, 212, and remainder is 1. it gives me a value of 32. The same way, 212, right? 212, remainder 1. 2510, remainder 1. 224, remainder 1. So it gives me a value of 128, 64, 32, 16, 8, 4, 2, 1. If you calculate this, you'll get to know how we derive this value. Right? Here it comes. 1 minute. Let me redo this one more time. Maybe you might feel this is confusing. First time, I'll make it slower to understand better. Let me take 255. Okay. So as I told you, you have to divide this 212, 224, 224, remainder 1, right? 2612, 212, remainder 1. Sorry, guys. I think a little bit of confusion here. Let me take 255, 212, 224, 224, remainder 1, 2612, 212, remainder. Wait, I think I have a little bit of problem in doing this subnetting. So if you actually split like this, okay, let's consider this way. That's a little bit of hard way of doing. 128, 64, 32, 16, 8, 4, 2, 1. So if you calculate all these three, all the 8 values, you'll get 255. So this is 8-bit addressing, as I told you. So in the same way, you got 4 blocks. Okay, in every block, you get the same value. Every block, you got the same value. And if you calculate all together, it comes 255.255.255. Now let me go back to one IP address and do a subnetting. Say, for example, let me take 192.168.0.0. And for class C, this is the default CIDR value. What do you mean by 24 here? See, in every octet, I got 8 bits. 8, 8, 8. So 3 into 8 equal to 24 bits. Right? So how do I fill that? 128, 64, and goes on till 1. 128, 64, 32, 16, 8, 4, 2, 1. The same way, 3 into 8, 24. And all these 3 octets, this is called network bits. And the remaining 8 bits here, because this is 32-bit addressing, right? And remaining 8 bits, it's for host bits here. This is host bits. So let's take another example. 10.0.0.0/8. And I got only this octet. This is for network. And these 3 octets is for host bits. So here I got 8, and you have to make it always power of 2. So this is what? This is network bit and this is host bits. So 3824, 2 to the power 24 minus 2. Why minus 2? Because if I calculate this value, 2 to the power of 22, I get a value, right? X value minus 2. Why? Because, example here, I'm just writing down this big number. I will use the subnet calculator for it. But for 2 power 24, say for example, it is 8096 something minus 2, because this 2 values, one for network address and the other value is for broadcast address. this cannot be used, cannot be assigned to any host. So what is the default CIDR value of class C? This is CIDR 8, because 8 bit for network bits and other 24 bits is for host bits. So how to calculate the host bits? 2 to the power of bits. So I got 3 octet, 324, 2 to the power of 24 minus 2, 1 for network bit and 1 for broadcast address. So let me do one thing. So if I've been given with this address, in my organization, I've been given with this address. Yeah. And somebody who is in charge of, he's giving a task and he's saying, hey, come on, split up this to something like 8 networks, 10 networks, whatever it is, but I need 200 hosts. But don't waste the network bits, just make it as a 200 hosts, that's fine. I want 200 hosts. How do we do that? So the default value is 8. So I got 2 to the power 24 minus 2. But I just need 200 hosts. So what I will do, I'll go back to this, diagrammatical representation here. Now you can get it, what I'm saying. See, this is occupied, this is not occupied, so it's /8. Okay, so here they given us a /24. We'll take the same example, a /24. We'll take same example as /24. So let me take 10.0.0.0/24. So what happens now? See, 24, you have to focus here. The first 3 octet. How I come to know that? 3 into 8, 24. Because in every octet, if I say octet, I got 8 bits. 8, 8, 8. So 3, 8, 24. So that's the meaning of this. You have to convert. So from the same thing, you can find your subnet mask here. So if it is an 8-bit, this is a value, right? 128, 64, 32, 16, 8, 4, 2, 1. Same way, first block, 8 bits. 1, 2, 3, 4, 5, 6, 7, 8 bits. Same way it goes on, right? 128, 64, 32, 16, 8, 4, 2, 1. Next 8 bit. 8 bits. Then 128, 64, 32, 16, 8, 4, 2, 1. 8 bits. Now, how do I derive the subnet mask from here? Just change the values. These are all occupied, right? If it is occupied, then if you calculate all this, 128, 64, 32, 16, 8, 4, 2, 1, you will get 255, right? So my subnet mask is 255.255.255.0, as simple as that. So this is your subnet mask. So now let's find how to find the network address and broadcast address. So now you understood, right? What is the CIDR value and all that. So now I'll go and find the network address and broadcast address. If somebody is asking a question, very simple question, what is the network address and the broadcast address? So the first 3 bits I'm not going to change because this is network bits and this is host bits. So let me write my first valid address. It starts with 10.0.0. 0 is my network address. This cannot be assigned to any device. So what is my first valid IP? 10.0.0.1. First usable IP address. So what is my last address? Since I know 2 to the power of 8 minus 2, what is the value we get here? 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6, 7, 8. So it comes about 255 minus 2, right? All 8s. Octet is completely occupied. 255 minus 2. So let me write down the last address here, dot 255. This is my broadcast address. And what is my last usable IP address? 0254. Last usable IP address. If you understood this, this is very simple. This is first IP address and in the network, and this is the last IP address, and this is my network address, and this is my broadcast address. So what is broadcast address? Say, for example, 93.4 is your frequency set for your FM. If you tune this station with this number, everybody can listen this, right? This is broadcasting. If you know if you try to maybe in your radio, if you try to set this frequency on your radio, you can start listening whatever is broadcasted. In the same way, if I try to ping this IP address, I'll get an ICMP reply from all the active hosts. It should be connected. So if that's used for, they call it as a ping sweep, because I cannot go and check every single active devices in my network. It's taking a lot of time for me. I don't want to do that. I'll just ping the broadcast address, and what on all the active IP address will reply back for my ICMP request. So that's the use of broadcast address. And network address, what is the best example I can give you for network addresses? Maybe you got a street address. That's going to be same, right? Example, this is XYZ street. And you might be, your home has an address of 2, second house in a street. Someone else in the third house, say for example, he's a Bob, he's John. So his street address is going to be same, and only the house address will be changed. That's the identity, right? Street address followed by the house address. Example, I'm saying to make it simple. So if I want to send any courier or maybe any post to Bob, all I do is I'll type, okay, XYZ and house number 2. It will be delivered. In the same way, when it comes to IP addressing, 10.0.0./24. So what is my network address for all the PCs? 10.0.0.0. This never going to change, right? And this is like your street address, and this is your house address. 10.0.0.1, this first address. What is the last address? 10.0.0.254, last address. But my network address never change here. It's always going to be the same, 10.0.0.0, right? And everybody's using same subnet mask. All the users within this range. So now my criteria is the task I got from my manager or someone who gave me this task. He said, hey, I want to have a 200 address. So now I got from 1 to 254. I got 254 usable address, and I can use this 200 address for the PCs. So how do we start assigning those IP address to the PCs? Example, here you got 10 network now, /24. So this is your PC, and you're creating your interface VLAN. Let's say it's 20 and 10.0.0.1. First IP address is given for this interface as a gateway. And 255.255. 255.0. This is my subnet mask. And we know how we derive the subnet mask. That's it. Two parameters, IP address followed by the subnet mask. My interface VLAN is created. So how do I'm going to assign the IP address back to the users connected to the switch. 10.0.0.2, 10.0.0.3. It goes on till 10.0.0.254. I can use 255.255.10.0.0.0. No, that is used only for broadcast. That cannot be used for any host PCs. That's the reason we divided 2 power 8 minus 2, because one for network and one for broadcast. So this is the ideology of subnetting. Basic high level overview about what is subnetting and how we are deriving this details, how this calculation has been done so far. Why we are calling this as a CIDR? Because why they call it a CIDR? Because this become a classless address, because the 10 network by default it comes with /8 as CIDR. But this has been changed to /24. It becomes a classless address, right? Because by default only 8 bits. That's the first octet is assigned for network. But I don't want to waste all this, This is all I want my network to be more, and I want a less host. It always starts from left to right. If you increase your bits from left to right, what happens? You get more networks, but less host. But when you move backward from right to left, you get more host, but less network. That's the key concept here. Now I'll go back and show you, you will understand now. So these are all host bits here. They said this is, one minute, let me zoom in. 10.0.0.0/24, and the host bits is last 8 bits because that's not occupied in 32-bit addressing. 24 bits is occupied for network address, and last 8 bits is for host bits. The borrowed bits will look later, will confuse now, but for now we have to understand how this IP schema has been done. See, 24, that's equal to 8 plus 8 plus 8, 3824. And last bit is been given for host. So it should be in the power of 2, 2 power 8 minus 2. Can you see this? This is class AC. The network ID, they said they separated in the the octet into 4 segments. So the first segment is the network ID that's occupied. So 8 bits is occupied. So remaining you got 2 to the power of 24 minus 2. But here 2 power 16 minus 2. Here 2 power 8 minus 2. Class A, Class B, and Class C. Here with this range, 172 and 16.0.0 would be your network address, right? And only the 16 bits are occupied for network, only this segment. For network, and these 2 segment, 2 to the power 2 power 16 minus 2, that's used for host bits. So let me do one thing here. Okay, you can unmute yourself, and you can ask questions, because this is subnetting And the objective is to understand the IP schema. If you have any problem in understanding this, let me know. We'll go through one more time. But the objective here is to, you guys should understand, the basic IP schema, and what is CIDR and what is IP address, and how it is, distinguished, and all that. Please free to ask questions. I think you have mute permission now. You can ask questions if needed. Am I audible, guys?
Yeah, you are audible.
Okay. You guys have any questions related to subnetting?
Can you just explain this classless interdomain and classful interdomain?
No, that's fine. I'll explain, but you got it. What is the difference between class A, class B, and class C?
Yeah, I got it.
You got it, right? But everybody, they understood what is the difference between class A, class B, and class C? That's a primary objective. Then I'll explain one more time. But just want to understand, it's very difficult to follow the IP addressing, because this is very important for, this is the basic foundation. If you are confused with this, then we cannot understand anything at all, because this is very fundamental and very much you should be aware of this. Only then you can do, whatever concept that's hardly rely on IP addressing. Guys, can you please be on mute if somebody's maybe we cannot hear properly? Guys, guys, if you have any question, just raise your hands. I'll unmute you and we will start from there. Yeah, I think Dheeraj, he asked a question, right? I didn't see him. Yeah, Dheeraj, you can ask question. I not see your name here. Hi, Dheeraj, you can unmute and you can ask your question. Anybody else? Okay, I can take up as you guys are understood, and let me move on. Yeah, you can ask questions. Ravi, Shambhu, you can ask questions, sir. I gave permission.
Hello.
Yes, Ravi. Yeah.
Yes, sir. You explained for every bit we have a 120, 255, 255, and at last, in the class you explained that 255, 255 at end is 0.
Yeah.
Yeah. Means in the last bit is 0, means the range is in between that one, right? For that only the last bit will get 0.
As I told you, so if you actually see this is you understood this, right? You should use the binary and decimal conversion here. So the ideology is this 255 is split into 8 parts, decimal values. So 128, 64, 32, 16, 8421. Right? Okay. If you add up all this, you'll get 255. In the same way, we got 4 octet, 4832. Got it? You got this point. But here, this host bit, if I make it a /24 here, what do you mean by /24? So all these 3 octets, right? 1, 2, 3. 3 into 8, 24. So that's the meaning of this. The first 3 octet is for networks. That is not used for host. Right? How do you represent that? First octet, if all the bits are filled, then it is 255. Followed by this, the second octet, all the bits are occupied, so it is 255. So the value comes as in 255.255.255 because last 24. So remaining 8 bits, this 8 bits for host. That's the reason they mentioned as last 24. First 3 bits is for network bits, and the rest 8 bits is for host bits. Here, see, all zeros, not occupied. So it should be the power of 2. 2 to the power of 8 minus 2. 1 for network and 1 for broadcast address. That cannot be assigned. As I explained you, I gave you an example. That's something like your network address is your street address, and your broadcast address is, I gave you an example as an FM. If you try to set the frequency on your radio, you can hear what's going on. The same way, if you ping this IP broadcast address, you'll get a reply from all the active IP address in the network given range. So here for this notation, the broadcast address would be 10.0.0.255. This is the last address, and this is broadcast address and cannot be used for clients. Understood?
Yes, sir. Thank you.
Okay. And yes, guys, I mean, there are 2 more questions. Already somebody asked a question. Who's that? Ravi, and I don't know who is this 1802566 Gagan Sharma. I can consider no one has any question.
Basically explore more little bit on class D and E.
No, class D and D for today, definitely it will be a confusion. I'll definitely explain this tomorrow because anyhow, the class D and C, that is just a range. You're never going to use this. You cannot use the class D and class E. Class E is reserved and class D is just, I'll show you the range for class D and class E, but you will never ever use in your life for, configuring the host devices. So I don't want to confuse that since there's a day 1 for subnetting. So that's the reason I just give you the example as simple as possible. I'll show you the values, no worries with that. I'll definitely share the details tomorrow.
Can we do practical on these classes?
Practically I will do right away. We have been assigning the IP address, and I'll show you how do I create the.
No, regarding class D and E.
No practicals for class D and D. As I told you, this is used for multicast address. In the upcoming classes, you will learn about EAGRP and all the routing protocols, something like OSP. If the EAGRP, it uses a multicast address. That's multicast is for one to many, right? So what if you have 3 to 4 routers, and if you configure your EIGRP, you have any idea about EIGRP routing, dynamic routing? If you configure the EIGRP, generally the ideology is it sends some frequent updates about, if you make any changes to your EIGRP in this particular router, it make use of this multicast address, something like 224.0.0.1 example I'm saying.
Okay. We will do it later.
Yeah. From this range, it sends the information back to all the active EIGRP routers. So it will come to know, okay, this is a topology change and he added a new network. So instead of just sending to every single router, the ideology is it just multicast this packet out of this IP address, and all the routers will get this detail.
Great. Okay, thank you.
No problem, sir. So any other questions? And I'll give some kind of exercise you can do at home, practical exercise for subnetting, and you find what is the number of hosts, and what is the first usable IP, last usable IP, and how many networks you got. Now we'll look little bit more about how we can separate the number of networks. What happened? I think I have a network connectivity issue. Guys, you can hear me, right?
Yeah, we can hear your voice.
Yeah.
Oh my God, my whiteboard is not working. I think I lost connection. Close this. 1 minute, guys. Let me try to open my whiteboard. It's not working. Whole thing crashed. Okay, no worries. Let me try to explain with a different notepad. Well, let me use a notepad here. So let me take this as an example, 10,000. Now let me give the value as 26. Okay. Now I'm saying this, how many networks I want here. Maybe let me take this example. This would be, perfect simple. I don't want to confuse you guys. So 168.0.0 and /24. As I shown you, the default CADR for class C is 24. So in my organization, they are saying, I want 4 networks, 4 VLANs. How do I create that? So as I told you, this first 3 blocks that's assigned for network
Network ID.
Network bits, right? So only this 4th octet that's used for host. But now the objective is to make 4 networks. How do I do that? So as I told you, if I keep increasing the bits from left to right, what happens? My network bits grows, right? It increases, and host reduced. So 192.168.0.0/24, it's just giving me 1 network. That's it, right? Because all these 3 octets is occupied. This is for network, and this octet is for host. So if I want 2 networks, 2 to the power of 2, 4, I'll get 4 networks. So I want to borrow the bits. That's a, example they have shown you in the whiteboard, but unfortunately, I don't know, something crashed. I lost the connection to the whiteboard. But generally, this is called borrow bits. I'll try to explain this. So I got, 255.255.255. This is all occupied, right? 888, 1 octet, the octet representation. So here I got 1, 2, 3, 4, 5, 6, 7, 8. Everybody would agree this, right? So I want to borrow 2 bits here because I got the CADR value 24 that satisfies here. All my network bits is occupied. That's the representation /24. I want 2 more bits. I should borrow this 2 bits from the 4th octet. So how the value will change? It's 24 plus 2, 26. So this becomes 26 now because I borrowed 2 bits. So how many host bits remaining? I'll represent in zeros, 6. 2 power 6 minus 2. So what is the value? 2 into 2 into 2 into 2, 2, 2. 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32. So 32 minus 2. So 30 host, right? In every network, I'll get 30 hosts. This is how I derived the values because based on the host bits, make it to the power of 2. The host bits 1, 2, 1, 2, 3, 4, 5, 6. Because this 2 bits has been given for network now. Earlier, the network bit was 24 and now it becomes 26 because I borrowed 2 bits from the 4th octet. Why? I want to increase my network bits because by default, this cannot be used because this is fixed value, right? Because this is a class C address and I'm just borrowing 2 bits and making my network. Got it? So let me write in this representation 128, 64, 32, 16, 8, 4, 2, 1. So what are the bits occupied? These 2 bits are occupied. Right, 24, 25, and 26. So what is my first address? It starts with 0, 64, 128. So it should be an increment of 64. So you have to consider this where the last bit that ends with, see, the network bits is 24 and I have borrowed 2 bits, 1, 2 in the 4th octet. This is only the 4th octet, okay? And it ends with 64. So 0, 64. So 64, 64, 128. And 128 plus 64, 12, 6, 7, 8, 192. So from this, what I got this value? 0,
192.
64, 128.192, right? So let me make it simple like this: 192.168.0.0/26, and the range starts from 192.168.0.0, 64, 128, and 192. So the value starts from 0 to 64, right? So 63 is my broadcast address. Guys, this comes with practice, broadcast address. Do the same kind of, I'll give you some exercise. You do this and come back with this. This can be, you can make it easier only by practice. You cannot get it in for the first time. Yeah, but you can understand the basic, the segmentation, how this can be do, the steps you can definitely, you have to listen, and you have only by practice you will get to know. So this is a broadcast address and this is next network address, because because I want to get 4 network. That's the reason I borrowed 2 bits from the host, 2 borrowed bits from the host bit. Yeah, this is network address and this is broadcast address and this is next network address, and 191 is my broadcast address. Let me write down here clearly. So it's 192.168.0.0 first network, 192.168.0.1 first host, and 192.168.0.63 my broadcast address, and 192.168.0.64 next network address. And I said, since the block, I borrowed 2 bits, 128, 64, 32, 16, 8, 4, 2, 1. And my bit, I borrowed 2 bits. So I'm making a representation with, binary. I'm filling this because 2 bits out of 8, right? 128 and 64. And my last bit ends with 64. So it's an increment of 64, 0, 64, 128, and 192. So 1 to 63, 1 is first usable IP, and 63 is the broadcast address, and 64 is the next network address, and and then 128 is the next network address, and 127, 192.168.0.127 is the broadcast address of, this is first network, this is second network, right? And this is third network, 128. And this is 192 and 191 is the broadcast address of third network. So this is 192.168.0.128 and 192.168.0.191. And it again starts with 192.168.0.192 next network address, and usable IP 192.168.0.193 till But next again, you have to add up this 192 with 64. 4, 5, 6, 9, 10, 15, right? 256. Total is 255 can be used. So it ends with 255. You got it. So this is the network address. 192 is the fourth network address, and 255 is the broadcast. You got it? Guys, this is very important. Okay, you should definitely understand this. Without this, you cannot do subnetting. You cannot understand networks at all. So I would say you try to understand, but the very beginning, for the first time, it's difficult. I told you, you have to practice a lot. Something you can make your own way of doing the steps. But the key thing is the way which I explain is the very easiest way. Say, for example, if I make .0.0, and if I want to make it as a /27, how I got this value 27, you can work out. So you can find how many networks. If I make it as /27 CADR, for /27 the CADR, how many networks I get. So I am just concentrating on the last octet because this is class C, right? I want to just focus on the last octet. So 128, 64, 32, 16, 8, 4, 2, 1. So first 24 bits is occupied for this, and I'm going to borrow 3 bits. Right? 25, 26, 25, 26, 27. Borrowed bits. Because the CADR value is /27. So /27 here. From the CADR value, I can make a calculation like this. 24, see, 3, 8, 24. 8, 8, 8. And remaining 3, 25, 26, 27. I borrowed 3 bits. So how my network now looks like? 192.168.0.0 first network. Then the second network, 192.168.0.32, right? Because it ends, my octet, the borrowed bit ends on 32. So 0, 32, and the increment of 32 is 64. 64 plus 32, 6, 96, right? So 96, 32, and 64, and 96. You can write like this. It's very easy for you to do the calculation. 192.168.0.64. And how do I calculate from the CADR value? How do I calculate the subnet mask value? See, only these 3 bits are occupied. So 24 bits already occupied. So it is 255 because first octet 8, second octet 8, 255. Third octet 8 bits are occupied, 255, and borrowed bits is 3. So 128 plus 64, 32. 8 plus 4, 12, 13, 14. Right? 6, 7, 8, 9, 10, 11, 12. 224. Dot 224. So I got the subnet mask value by looking at the CADR value. If I make a conversion, I'll get the subnet mask value here. So for all this network, this is going to be the subnet mask value, common subnet mask. This is how the differentiation is happening. This is how we are doing the subnetting inside. So what is the last network address? 168.0.96. This is second network, and this is second network. This is the last network. Guys, can I ask a question? What is the first usable IP address in the second network? Anybody know the answer?
33.
What is the first usable IP address in this range? 192.168.0.32. What is the first IP address?
192.168.0.33.
Awesome. So what is the broadcast address of the second network? Broadcast address.
0.63.
Great. So I think you understood, right? Okay. So you got it. How I am calculating the subnet mask. So let me give you one more simple exercise here. I'm not going to do anything here. You guys will going to find this. Let me take same example 192.168.0.0 and /29. So what is the subnet mask value now? Anybody know? Sorry?
255, 255, 255.248.
255.255.255.258. Is it?
48.
248. Okay. 128, 64, 32, 16, 8, 4, 2, 1. And how?
224.
Yeah, 224.
224. Okay.
Yes.
Okay.
No.
So let's calculate now. No worries. See, 24 bits, that's already occupied. We should ignore that. So 24 plus how many bits we have borrowed now? If it is 29, 24, 25, 26, 27, 28, 29. Right? You said the subnet mask is 224. So it's 128 plus 64 plus 32, 16, and then 8, right? 24, 25, 26, 27, 28, 29. So I have to calculate all these values to get the subnet mask value. So 8 plus 4, 12, 12 plus 2, 14, 14 plus 6, 10, 20, and 8. 2, 6, 8, 10, 13, 14. 248 is a correct answer. Why do you confused? Your first answer was correct. It's 248, not 224. Because you have to calculate these values. You got it, what I'm saying? See, 29. So 24 is already been assigned. By default, it got 24 network bits, class C. So I am borrowing, how many bits? 1, 2, 3, 4, 5 bits. Right? That makes 29. And if I calculate this, I get 248. Now you got the subnet mask value. In the same way, see, right from here, you'll get all the details. I got my subnet mask value and how the network looks like. What is the block size? This is called as a block size. Your host block size, it starts with 0, 8, 8 plus 8, 16. So from this, you can calculate your network 2 to the power of 5. How much? Any idea? How to calculate 2 into 2 into 2 into 2 into 2.
32.
Since the day one class, I'm doing this. How much? 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 to 32, right?
32.
Yeah, you have now, how many networks you got now? 32 networks you can create. And how many address you can assign for every host? Just 8 hosts. This works with logic, right? If I get many networks, I got very less host. If I got more host, less network. Vice versa. We are all playing around with this 255. That's the simple logic behind subnetting, I would say. Your value will never exceed 255. And we are just playing with this 255. And you should understand this block size. So it goes like this: 0, 8, 16, 16, 8, 24, 24, 8, 32. So the same way, if every network has 8 hosts, you got it, what I'm saying? 0, 8, and 6 hosts, because one for broadcast and one for network. This cannot be used, and this cannot be used. 7 is your broadcast and 6 your host. So every block has 6 hosts inside. I'll tell you again, this is how you can change this as you wish. 192.168.0.0, and you guys try to make /30, right? And 192.168.0.0 and /27. 192.168.0.0/25. 192.168.0.0/28. Just make a note of all this and try to find out what is subnet mask, how many host network for all the four. Okay, for all the four, how many hosts inside this network, and what is broadcast address, and what is network address. That's it. If you are able to find this, then maybe you started getting with subnetting. That's it. Then it's pretty simple. You can understand. Please guys, make a note of this exercise. I want, everybody should do this. Take a pen and paper, okay, and do this work. You'll definitely get it. If you have any questions, please free to ask me tomorrow. I'll definitely help you, but you have to work on this. Only then you will understand, because just this is this involves some kind of mathematics, simple, not a big rocket science, but still you have to practice. Only by practice you keep, because this is very important. You'll be given with this for everywhere, the DNS server, your DHCP server. They will say you have to create 4 networks. How you'll do without knowing this basics? You cannot do it. You can verify your answers also, but there is many tools like IP subnet calculator, but don't rely on that. Do a manual calculation. That's very important, because the IP subnet calculator will give you, definitely it will give you a value and answer, but how do you know that's correct? You should have this understanding, and using the IP subnet calculator, you can verify. You make use of this to verify your answers. And in the tomorrow's class, I'm so much interested. You guys should turn around and ask me questions, and if you do this exercises at home, this is really benefit for everyone. I'll unmute. It's not muted, right? You guys can ask questions. Everybody, I've noted this. Please make a note of this. Yeah. Hi guys, everybody there? You can hear me?
Yeah.
Yes.
Yeah, it's noted.
Yes,
Please,
sir.
please make a note of this and do this exercise. I'm repeating again. If you're not familiar with this subnetting, then whatever the concept we cover, I mean, that's fine. But without IP addressing, you cannot do anything. This is very basic, fundamental, and you should understand. Just do this way. This is all very simple. Whatever I gave this, I need 4 details for every network, for every segmentation I have made here. Network address, what is the broadcast address, what is the subnet mask, and how many hosts inside this network, every network. Yeah, come up with the answers tomorrow. We'll have a discussion tomorrow. We'll discuss the subnetting. I want everybody should understand first. Yeah. I hope everybody enjoyed the class today, and hopefully we'll catch up tomorrow. Yeah.
Yes, sure.
Okay.
Yes, sir.
Okay.
Okay. Thanks. Thanks, guys. Yeah.
Okay.
Thank you.
Bye-bye.
No problem. Meet you tomorrow. Bye.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.